Hello everyone. In this lecture, we are going to look at the operation of the NOR gate and the exclusive OR gate. And now, let's right away look at the truth table for an OR gate. An OR gate is basically an OR gate that has been negated. In other words, the output of an OR gate is going to be negated or is going to be passed through a NOT gate. Then that output is going to be for a NOR gate. So when you input a high and input a low in the NOR gate, the output is always going to be low. When you input a low and again the other input is high, the output of this NOR gate is always going to be low. What if you have all the inputs being low? The output is going to be high. What if now you have all your inputs being high? The output is going to be low. So let's go and verify the results of this truth table in our circuit simulator, Multisim. So right away, let's go to the basic components and we put our components. We have a switch, which is a single pole, single throw. We shall need two of them. Then we shall also need a power source. Let's use a DC power source. Then we shall also need a ground. It is a normal and good practice to ground your device. Then we are going to also look for an indicator, of which we are going to use a 4 volts 0.5 watts bulb. So we are left with getting our NOR gate. So what we are going to do, we are going to get our NOR gate that accepts two inputs. So we take it here. Let's close this. Let's expand this and then do the connections. Our transistor logic gates always work within a voltage range of about 5 volts. So let's do what? Let's change this battery source to 5 volts. Then we connect our inputs here. They are going to be controlled via switches. So this is our NOR gate. Then we rotate our indicator through an angle of 90 degrees clockwise. We connect our output to the indicator. We connect our indicator to the ground and also connect our negative battery terminal to the ground. So now this is our NOR gate. So our NOR gate is going to give results that are opposite to those of an OR gate. Now, let's run this circuit and we see when all the inputs are low, the output is high. You can see all the inputs are low, the output is high. And when any of the inputs is high, the output is low. So let's go and verify that one also. Any input is low and the other one is high, we are going to get a low output. Then any input being high and the other one being low, the output is low. When all the inputs are low, when all the inputs are high, according to this truth table, the output is low. So since we are not receiving any light from this battery, then we shall say the results of the truth table have been correctly verified with the Multisim. So this is how a NOR gate operates. Let's right away go to the exclusive OR gate. So the exclusive OR gate works like this. It always outputs a high state, or the output is always going to be high when in one of the inputs there is a low and there is a high in another input. So we have two inputs, one of them is high, another one is low. The output of that gate is always going to be high. So when you have all the inputs the same, low, low, you always have a low. When all the inputs are the same, high, high, you always have a low. So let's verify this truth table in Multisim. So we already have these components. Let's just go ahead and import our XOR gate. So let's look for the XOR gate. So let's take the XOR gate, or the exclusive OR gate that accepts two inputs. So let's connect our system, first flash the past results, and then let's connect our output to the bulb, or the indicator. So when we run this simulation, we are going to see that we are always going to have a low because all the inputs are the same. Okay, now it is running, but you can see we have a low output. What if they are the same by giving them high value or high state? Still, the output, when I run this simulation, the output is low. So what if one of the inputs is low, another one is high? You see, the output is high. Let me close this switch and open this switch. So one is high, another one is low, still the output is high. So this is how an exclusive OR gate operates. The results have been verified using this circuit simulator. Thank you.